Hello and welcome to my channel. I hope you all are doing well. In this video, I will show you how to control brushless motor using Arduino. Before that, I would like to share with you some uses of brushless motor. So brushless motor is commonly used in small scale remote control aeroplanes. It is also used in quadcopters for video filming, which are commonly used in video filming, etc. Also in remote control helicopters and remote control cars. The basic component used in these applications is brushless motor. It is used due to its remarkable high speed and efficiency. Now let me briefly tell you how we are going to control this brushless motor using Arduino. Basically, we will generate a scale wave from Arduino through its PWM output function. Then we feed that scale wave to electronic speed controller, and in return ESC will control the speed of motor according to the wave. But the question here is, why are we using the scale wave as an input to electronic speed controller? Well, the electronic speed controller works in the same way as of servo. And if you don't know the way of the servo, I will tell you. The basic principle of working of the servo is that we provide servo with a scale wave of time period 20 milliseconds as an input. The maximum pulse width of single pulse has the value of 2 milliseconds and the minimum pulse width is of 1 millisecond. By changing the pulse between these ranges, that is from 1 millisecond to 2 millisecond, the servo rotates from 0 to 180 degree according to the changed value. Let us now come back to our ESC example. The same wave of time period 20 millisecond is provided to electronic speed controller, and the pulse width is controlled between 1 millisecond to the 2 millisecond in the same way as we have controlled as the input to the servo, which results in changing the speed of brushless motor connected to the electronic speed controller. That is, at the pulse width of 1 millisecond, motor will have its minimum RPM, that is 0. And similarly, at pulse width of 2 milliseconds, the motor will have its maximum RPM depending upon the upper range of particular motor. Now I will show you some animation of the changing pulse width and the increasing and decreasing RPM of motor. For example, we have a motor of maximum RPM 100. In the beginning, the pulse width is 1 millisecond and the RPM of motor is 0. If we change the RPM from 0 to some higher value, the RPM of motor is also changed. For example, before changing, the RPM was 0, and after changing the pulse width greater than 1 millisecond, the RPM has changed to 5. Now the pulse width is slightly more increased, and again the pulse width and the RPM has changed. Similarly, we can control the RPM of motor by changing the pulse width of this scale wave. So here is the setup diagram or circuit diagram of controlling the brushless motor with Arduino. The motor is connected to ESC. The electronic speed controller is powered by 3S LiPo battery having an output voltage of 11.1 volts. The output cable of ESC is connected with the Arduino, the positive 5 volt wire of ESC with the positive 5 volt of Arduino, and the ground of ESC is connected with the ground of Arduino. The data wire is connected to the pin 9 of Arduino. You can use any PWM pin as an output. I have used the pin 9. The hint is the PWM pin has a tilde sign before its numbering. Potentiometer is used to take the input reading, which controls the pulse width of input scale wave. The data wire of potentiometer is connected to analog pin A0. Again, you can use any analog pin you want. I have used A0. Now the circuit diagram is complete. Let us move to the code section. The code is pretty simple, as the input of signal of ESC is totally same as of servo. So we will use the code of servo knob to control the ESC. You can get the code by simply clicking files. Then in examples you will find servo and then click knob. Okay, here is the code. I will make some changes in it. I will change some variable names to make it more understandable. First of all, the servo library is imported. Then the object of servo class is made. Here I will change the name from my servo to ESC. Then an integer type variable is initialized. I will also change its name from pot pin to, I think, thrust. It will control the speed of motor. And then again the integer type variable is initialized, name value. In the void setup we have only one line of code, my servo dot attach. Okay, I have attached the ESC in pin 9, so I have passed pin 9. It is already by default it is 9. Here from ESC I will change it to ESC. And coming towards the while loop, first of all we get the value. We will get the value from the potentiometer. Name the pot pin, which I have earlier changed its name to thrust. Okay, here the thrust, we will initialize the thrust with analog pin A0, as we have attached the pin of the potentiometer to A0 as an input. Now the potentiometer gives us the value which is between 0 to 183, 1023, that's 1023. It's for 5k potentiometer. But I am using 10k, but there is no need to change that value. It works perfectly fine with 10k also. Here's the output range of the potentiometer, which a mapping function will convert this range into this range. From 0 to 1023, it will generate values from 0 to 180 degree, and the pulse width of the square wave is changed according to this value. Then we simply send that value between 0 to 180 degree to our electronic speed controller, which in turn controls the speed of motor. Here we will remove the delay of 15 milliseconds. We simply don't need any delay. Now that's all about the code. It's pretty simple. Now we will upload the code. My servo, okay, ESC. And now the code is uploaded. So here's the setup, and we have uploaded code and the motor is running. Before running the motor, make sure that your ESC is calibrated, and to do that, first we have to remove the plug of a battery. Then we have to make this to its highest position, highest value, and then we plug in. When we listen the two beep sounds, we rotate it back to its initial position and the ESC will be calibrated. Now that's all. Thanks for watching.